Once I lost.
Okay. Hi, this is the memory office hours, and we have Sean, and we are going to discuss a little bit the future Redis work that memory team will assist. So,
Yeah,
Sean, welcome.
Thanks, Nicola. So yeah, just I'm sure people have already read the epic, but just to give a bit of background. So, like when I joined GitLab, which was like 5 years ago, we only supported one Redis instance. So like we use the same Redis instance for the cache, for session storage, for Sidekick queues, which was not a great idea. Community contributor partitioned it into 3. So cache, Sidekick, and everything else, which we have a few names for. So like in dashboards, it's just called Redis. In the code, it's called shared state. We often refer to it as Redis persistent because to distinguish it from the cache, which is least recently used. And has an eviction policy. So that sort of functional partitioning has worked for us for a while. But lately we've been bumping up against some limits especially as we use Redis more. So for instance, we supported rate limiting for a while using the rack attack gem, but we didn't actually use it on GitLab.com. Recently, we enabled it on GitLab.com, and there was a noticeable increase in the cache usage because rack attack uses the cache instance by default. So currently, we in the scalability team are working on splitting out the rate limiting instance from the cache instance to, isolate that workload and give the cache a bit more headroom. We had a lot of network traffic on Redis persistent when we rolled out our new job traces architecture. So that goes, let me get this right. So I think previously our job traces went into the database and then potentially into object storage. Now they can go via Redis into object storage. Which, because it's such a write-heavy workload, the database was kind of a painful place to do that. That reduced a small amount of CPU usage from the persistent Redis, but it reduced a lot of network traffic. Again, because it's such a write-heavy workload, it's not necessarily complex for Redis to deal with, but it is, a lot of data. And now we're looking to also split out the session keys from Redis persistent. So at the moment, Redis persistent, Redis shared state, Redis whatever, is kind of a everything else, like I sort of implied from the first split. Like it's stuff that's clearly not a cache, and clearly not related to job queues, and clearly not related to trace chunks, and clearly not related to rate limiting, is basically what it is. So it's everything else. There are a few ways we could split this. And like it has things like e-tags for HTTP caching. It has the hyperloglog counters we use for our product intelligence stuff for like particular actions. It has sessions, obviously. It has database load balancing write locations, which I'm sure Nicola will know about because she's been doing a lot of work on database load balancing. It has runner build queues, I think, as well. And, just other general stuff, basically. So a disadvantage with pulling sessions out is that pretty much everything else I mentioned is stuff that we at GitLab own. So like the entire code base, like the entire, like everything that writes to that key or reads from that key is in our code base in the first place, whereas sessions we're using third-party libraries in some places. So that makes peeling out sessions potentially a bit more of a challenge. I'll be honest, I haven't looked into the details of peeling out sessions too much so far, but it also gives us an advantage in that, first of all, they're responsible for the most storage on that instance, and secondly, it's a very clear separate workload, and we can also confidently set an eviction policy on the sessions instance, because while we want sessions to stick around, the alternative to an eviction policy is that Redis just falls over, and nobody can do anything on GitLab. So logging people out sooner than planned is not ideal, but is slightly better than GitLab is completely down. So yeah, I guess that's the background behind it. We don't know how much CPU reduction we will get from this. We have the first issue in the epic is to get that. I'm honestly not sure how we will get the CPU reduction. We can certainly get the data size, but the CPU reduction might have to be an estimate just based on like the number of commands that we see and what type of commands they are. I think most of the commands for sessions are fairly efficient ones. They're not particularly complicated commands. So I think the space reduction will be bigger than the CPU reduction. And the other week, I don't know if this is linked in the epic actually. Yes, it is. There's a link to a recent production incident under why did we choose to move session keys next, where due to a combination of factors, which there's more detail on the confidential issue, we saw a rapid growth in session storage on the shared state instance, and it got pretty close to getting OOM killed. And we were also pretty close to running out of disk space for the backups on the secondary, so it would have been even worse than that because we wouldn't have even had a recent backup to restore from. And that would have happened before we got OOM killed, so it would have been pretty bad. Obviously, for that, we should, we need more disk space on those nodes. That's a different issue, but it was a bit scary. So yeah, that's the background. Any questions on that before I start talking about the work?
Yeah, I think you covered it. I wanted to ask like why we choose the sessions, and is there other candidates to split as well?
Yes. So the main other candidate was load balancing, because that's quite a high number of keys and it's quite a frequent, every request basically accesses load balancing information, just as every request accesses session information.
Yeah, and I put additional stuff there for the duplication work as well. So.
Yeah, yes, for Sidekick, yeah. So that was another good candidate. Again, like I said before as well, especially because we own that code, so it's easier to do. But the actual, although the number of keys is high for the load balancing data, the keys themselves are much, the values in those keys are much smaller than they are for sessions. So it wouldn't save as much space, even though we'd save a lot of keys. And also, if we have this instance, if we split what we currently have on there into stuff we control and stuff we mostly control. So stuff we mostly control being sessions, stuff we control being everything else. That also gives us the advantage that it's easier for us to look into using things like Redis cluster for the remaining data on that instance, because we own everything that writes to that instance. So we can change it to make it Redis cluster compatible if we need to, and if it's possible. So yeah. But I think the production incident was the main motivator there, in the sense that we've never seen key growth like that from load balancing keys. Space growth rather than key growth, whereas we have just the other week from sessions. So it's a bigger.
Just a quick question about load balancing. Like now we are doing this decomposition, and we will need actually now to support multiple databases, which means that we will probably store the write ahead location in Redis for each database, which will probably increase the load.
That's a good point. Yeah, so basically double the load balancing space size. Yes.
Did we measure something like that, or do we?
No, that's a good point. Let me just add a comment to that first issue, just to make a note of it. Yeah, and actually, the way you can think about this work is that it's basically the same as the database decomposition work in terms of what the end result is. It's just much, much simpler, because in Redis there are no joins. So
luckily there are no joins.
Yeah, so we don't have to worry about any of that. If we come across some kind of multi-key command that uses a session key and a load balancing key or something, then that would be a huge problem. But I think that's really unlikely. So it's the same concept. It's just much, much simpler with Redis than with Postgres for a bunch of reasons. In terms of the implementation, so we have sort of sketched this out based on the work we're doing with rate limiting, but rate limiting is simpler in a couple of important ways that means the project we're doing now is easier than the project we're asking you to do.
Not really.
So the first thing, the main thing that makes rate limiting simpler is that all of our the longest TTL we have on any rate limiting key is 3 minutes. So we've actually decided not to, and if we lose rate limiting keys, there's no negative user impact. Because, you know, at worst, we allow more requests than we intended to, but as long as we don't do that when we're actively like rate limiting a lot of requests, it probably won't have downstream effects on the rest of the service. So what that means is we actually don't have to care about migration data at all. Like we just say, we're gonna start using this new instance and stop using the old instance and forget there was ever any data in the old instance and just let that expire automatically. We can't really do that with sessions because we need to keep, well, we would like to keep people logged in. So we don't really want to log everybody out when we do this change. If it's the only way, then fine, but I think it's probably not the only way. So we've deliberately sort of left that undefined as to how we do that because we haven't looked into the details of how sessions are written, like what writes to a session, what reads from a session. I think there are a couple of sort of fairly obvious candidates initially for how we could do this. So one would be sort of several feature flags for multi-reading and multi-writing. So like, you know, we start reading from both instances for sessions, you know, reading from the new one, falling back to the old one. We would start multi-writing, whatever, you get the idea. Like, you know, we would have a period where we would read to and write from both instances, depending on how we'd configured things. And then after a period of time, we would only read from and write to the new one. Another option, which is more of an operational thing, and I'm not entirely sure how it would work, is that, so currently our Redis configuration on GitLab.com is each what we call Redis instance. So like the shared state instance at the moment has 3 Redis nodes. There's a primary and 2 secondaries. With Redis, the secondaries don't get any user traffic at all. They're just standbys. We could, I don't know exactly how it would work, but because those are secondaries, we could add an additional secondary, but then promote it to be the primary for sessions. And then we would have all of the contents pretty much of the existing shared state instance. But I don't know the operational details of that, as you can probably tell by the pauses in me saying that. So like that's a potential option. So those are the 2 sort of obvious ones, but there might be other options as well. Like I said, I haven't looked into the session handling code too much. Any questions there? I'm just going to add that comment that Nicola mentioned before we carry on.
Sounds good.
Okay. So that also, like I said, it's a harder project, but that also means that there's more backend requirements. So like on the existing project, it's basically 1 backend engineer and 1 SRE because, like I said, there's no data migration to do. So we basically just need to be able to flag on and off the new instance. In that case, we're using a feature flag for one and an environment variable for the other because Rack Attack is configured on application boot. So a feature flag actually makes it less certain when that applies, because if we applied a feature flag, we would need to wait for a new instance of the application to start up, but we wouldn't know when that would happen. If we apply an environment variable, it's more work because we have to do a production change issue, but we know exactly when that's going to be applied because it's when we make that change ourselves. So we have a bit more control there. Yeah, so, and obviously feature flags as well, because these are such high frequency locations, I think feature flags are probably okay to use because they're stored in process memory for a minute as well, but it's worth considering there about the overhead of those checks or of doing multi-reads. Sorry, my cat's just trying to knock everything on my desk over. So yeah. And yeah, I think the idea for this project is that we, probably Craig, who's based in New Zealand, will be doing the infrastructure steps needed, or at least like the main contact for the infrastructure steps needed, like actually provisioning these new instances, rolling out change issues, or at least reviewing change issues, etc. Most of the early work is fairly straightforward. So Nicola reviewed a merge request of mine yesterday, which was adding the rate limiting instance. Hopefully after that change, it's fairly straightforward. It's basically just a case of grepping for everywhere we use a Redis instance and adding a new one. So
it looks like that, yes.
Yeah. So it's mostly copy and paste and replace, which hopefully isn't too bad. And then similarly, we need to be able to support configuring it in both Omnibus and in our Helm charts, because we still use Omnibus on GitLab. Well, A, for self-managed, but also because on GitLab.com we still use Omnibus for the console nodes, and we use Helm for everything else, which is a bit confusing, but there you go.
Yeah. Yeah, configurations are very confusing, but I feel really relieved because it's more or less straightforward, like steps the same as you do for the rate limiter. So
yes, exactly. Like I said,
we can follow similar steps. Like the only difference is really like what we will do with migration. And
yes.
Is there anything else that we will probably need to pay attention for sessions?
I don't know. I think it's possibly worth getting in touch with, I think it's Manage Access, the stage group that owns sessions, just to see if they, there's something they know about sessions that will make this particularly difficult, or might even make it easier. So I mentioned using 2 feature flags earlier. I think that's sort of a generally reasonable approach for like multi-read, multi-write. But I don't want to say that we have to do that, because we haven't actually done it in the past. So when we split out trace chunks, because they could be stored in the database or could be stored in Redis, the database already had an enum that said, like, where is this trace chunk stored? So we just added another value to that enum that said it's stored in this Redis instead of that Redis. So we didn't really need to support, a feature flag for saying which Redis to write to in the same way. We did still have a feature flag, but that was just to turn on the feature. And similarly for rate limiting, we don't need multi-reads and multi-writes because we don't care. The data is just not that important, whereas sessions are much more important. So yeah,
but having that fallback sounds reasonable, even if we promote a node to primary or any other.
I don't know the exact details of how that would work, but I think when we initially split the Redis instances on GitLab.com, that's what we did. So that would have been like 4 years ago. So I don't know how applicable what we did then is to what we did now. But I think it's possible that we could look at something like that as well.
And I like that we already have this mechanism that you implemented for falling back if the configuration is not there.
Yes.
So if the new instance doesn't exist, we will still fall back to the default one.
Yeah. So Jakob Vosmer implemented this. So basically, the idea is that in the code base where we define the class for the new Redis instance, we say that this instance gets its configuration from another instance if it's not configured explicitly. So that means that self-managed instances, most self-managed instances won't even have 3 Redis thingies. They'll just have 1 because that's the default with Omnibus. But it means that we can get the configuration. If they've got 3 configured, we don't just as soon as they upgrade, we don't just fail because they need to configure a 4th or a 5th. It will just fall back to the correct one and use that, which is also handy for development as well.
Cool. What are the next steps actually? Like when we should start? Should we who is going to split this epic and create separate issues? I guess we are going to follow the same pattern and same tasks as we did for rate limiter and the rest, but
yeah. So for rate limiter, again, because it's simpler and because there's basically 2 of us working on it, we just went for bigger issues. Because if there's just 2 of you working on something, it's kind of easier to just work on one issue with a bunch of checklists tasks in it than it is to split into several issues. But when there are more people working on it, it makes more sense to split into separate issues so you can easily define who's working on what. I will get back to you on that. So the one constraint we sort of put on the memory team here was that we didn't want to overlap the 2 deployments. So we want to be finished with the rate limiting rollout before we start with this rollout. So I think we're aiming to start the rate limiting rollout next week. And then it's a question of like, did we think of everything, or did we get something horribly wrong and we need to go fix it? If we didn't think of anything, that should be fairly quick. If we got something horribly wrong, it could take a long time.
That's one more good reason to wait with splitting sessions as well.
Yeah, yeah, exactly. I think the analysis issue could be started now, but I think it makes sense to look at that maybe next week when.
I agree. I think that we need to take a look, maybe all of us, to take a look at the rate limiter issue and what is done there. Like I reviewed the MR, so I'm familiar, but probably we should all take a look what work was needed to be done. And also I need to finish rolling out the duplication back for load balancing. So.
Sure. Yeah. Exactly. You'll have your existing things that you're working on.
Yeah.
So I'll comment on the epic with that. I also need to ask who's going to be able to help with the analysis issue, because we've said like we want you to do that as the first thing, just to look at the existing data. But I think for some of that data, you will need someone with production access to help. So we need to figure out like who's responsible for helping you like actually get the access that you need to do that issue. First as well. So yeah, but throughout the project, the idea is that we're here to like help review issues or MRs or just questions. Like we're not, the point of saying like we haven't defined the rollout plan isn't to say like it's all on you. It's just to say like we don't know. Like please talk to us about it once you've investigated it, and then we can work together on it. But we didn't want to just like tell you this is what you have to do, because we don't have the expertise to say that.
Sounds good.
Cool.
Yeah, thanks. That was a great introduction.
Thank you. Well, I'm looking forward to working with you all on this soon. And we'll see how it goes. Like, feel free to like I said, we're doing this sort of fairly just in time in terms of like planning. So like feel free to say like if something's not clear, or if you feel like something's underspecified, like it probably will be. So we won't be offended to say like if you don't understand what we want you to do with something.
Thanks.
Sure. Yeah.
Cool. Well, I'm gonna go. Have a good one, everybody. I'll leave you to the rest of your office hours.
Yeah, thank you. Thank you
Yeah,
for
see
joining.
you.
And thanks for the
Thank
info.
you, Sean.
Have a nice Friday. Okay, I'll stop recording.